Greetings! Today we're going to talk about the square root property and completing the square. Let's first start off by solving by factoring. So we have the equation x squared plus 5x minus 24 equals 0. I do not see that it has a GCF, and there's no number in front of x squared, so we just need to find something that multiplies to negative 24 and yet adds to 5. It looks like 8 times negative 3 multiplies to negative 24 and yet adds to 5. Giving me the factored form of x plus 8, x minus 3 equals 0. We know at this point, according to the zero product property, that we set each piece equal to 0 and then individually solve them, giving us x is equal to negative 8 and x is equal to 3. But what if we can't factor? We know from previous lessons that sometimes we just can't factor, so we would list it as prime or unfactorable. But now we're going to be able to, even though we can't factor, we can still solve. So we can use the square root property, completing the square, and the quadratic formula in addition to solving by factoring. We're going to focus on two of them today, the square root property and completing the square. The first one is the square root property. It states that if we have x squared equal to a number, or it could be a variable, then to undo the square, we take the square root, and therefore x is equal to plus and minus the square root of a. So let's say we start off with x squared equals 81. To undo the square, we will take the square root of each side. However, that will also give us plus or minus the square root of 81. We know the square root of 81 is 9, so the square and the square root undo this x squared piece, giving us x is equal to plus or minus 9. Because if I were to plug in positive 9 to each piece, positive 9 squared is 81, and if I had negative 9 squared would give me 81. Therefore, both are required as part of the final answer. Here I have x minus 1 squared equal to 9. So I have that whole binomial squared, and we can undo the square by taking the square root of both sides. The square root on the left will cancel out the square, giving me x minus 1, and the square root of 9 is 3, giving me plus or minus 3. Now needing to get x by itself, I add 1 to both sides. But keep in mind here that I have two solutions. I have one solution where I have 1 plus 3, which is 4, and the other solution is 1 minus 3 equal to negative 2. So in this case, x is equal to 4 and negative 2. So actually follow through with the motions if we get some nice whole numbers that we can actually add and subtract together. Let's say I have x plus 3 squared equal to 7. Well, I can undo the square by taking the square root of both sides. This will give me x plus 3 squared, the square root of it will cancel, equal to plus or minus the square root of 7. Notice that I cannot simplify the square root of 7, so it just stays plus or minus the square root of 7. To get x by itself, I will need to subtract 3 from both sides. Again, we have two different answers here. I have negative 3 plus the square root of 7 and negative 3 minus the square root of 7. We're going to leave our answers here in exact form. I'm not going to write a decimal and combine them together. We will just leave them as so. Here I have x minus 1/5 squared equal or plus 1 equals 0. Let's try to isolate and get that square by itself. So I'm going to subtract 1 from both sides, giving me x minus 1/5 squared equal to negative 1. Then I'll take the square root of both sides so that the square and the square root cancel on the left, and I have plus or minus negative 1 on the right. We also then have x minus 1/5 equals plus or minus I. We cannot forget about the imaginary numbers. The square root of negative 1, we know, is the very definition of the complex number I. But x still isn't by itself, so we need to add 1/5 to both sides, giving me positive 1/5 plus or minus I. Again, we have two solutions here. One solution where I have 1/5 plus I and 1/5 minus I. Let's solve by completing the square. Here are the steps that we're going to take. First, we're going to put the equation in the form of ax squared plus bx equal to c. Note here that I have the x values on the left equal to our whole number or regular number on the right. Then, if a does not equal 1, we'll divide each term of the equation by a. Then we will square half the numerical coefficient of the bx value. So I'm going to take b, divide it by 2 and square it, and add the result to both sides of the equation. Step 4, we're going to factor the left side and then take the square roots of both sides of the equation. And finally, we'll solve the resulting equation for x. Here's an example. X squared plus 8x minus 1 equals 0. I'll first start by getting the x's on the left and everything else on the right. So I'm going to add 1 to both sides, giving me x squared plus 8x equals positive 1. Then, because x squared is by itself, there is no number in front of x squared, we can skip step 2. We'll see an example of when there is a number in front of x squared here in a moment, so we'll know what to do with them. So now I'm going to take half of the numerical coefficient of the x value and square it. So I'm going to take 8 divided by 2 and square it, which gives me 4 squared, which gives me 16. This needs to be added to both sides of the equation to keep it equivalent. I also highlighted the 4 piece because this is going to help us factor the left-hand side without even having to think about it. So we're going to come back to that in a second. So the part just before I square. This will give me x squared plus 8x plus 16 equal to 1 plus 16. We have created a perfect square trinomial by completing the square on the left. So to factor the left-hand side, I can take that highlighted positive 4, and it becomes x plus 4 squared. This will happen over and over and over again. We can use the piece right before we square to help us factor without thinking about it. This will become helpful when we have fractions as our middle term. And then 1 plus 16 is 17. Now we can finish off using the square root property from the previous slides, where I'll take the square root of both sides, giving me x plus 4 squared, the square root of it, which we know will cancel, equivalent to plus or minus 17. And finally, to get x by itself, we'll subtract 4 from both sides, giving me negative 4 plus or minus the square root of 17. Knowing I have two answers here, negative 4 plus the square root of 17 and negative 4 minus the square root of 17. Let's try 3x squared minus 6x plus 2 equal to 0. First, I'm going to put my equation into the form of ax squared plus bx equal to c. So I'll subtract 2 from both sides, giving me 3x squared minus 6x equal to negative 2. Then, because I have a number in front of x squared, I'm going to divide everything by 3 so that the number in front of x squared disappears. If I divide everything by 3, that gives us x squared minus 2x equal to negative 2/3. Now I'm going to take the coefficient in front of my x value, and I'm going to divide it by 2 and square it. This gives me negative 1 squared, and negative 1 squared is 1. Keep in mind the negative 1 in front of the square here. We're going to come back and use this piece here when we write it in factored form. I need to add 1 to both sides, so add the result to both sides of the equation. That will give us x squared minus 2x plus 1 equal to negative 2/3 plus 1. On the left, I have given myself a perfect square trinomial, and I will write it in factored form of x minus 1 squared, again, using this negative 1 to help us factor. In order to add the right-hand side, we need a common denominator. The common denominator for 3 and 1 is 3, so 1 is the same as 3/3. Negative 2/3 plus 3/3 is equal to 1/3. I am now able to take the square root of both sides of the equation so that I can eliminate that square. By doing so, gives me x minus 1 equal to plus or minus the square root of 1/3. We're going to do a little bit of side work here. I'm going to take plus or minus the square root of 1/3 and make it plus or minus the square root of 1 over the square root of 3. I know the square root of 1 is 1, and the square root of 3 is still the square root of 3 since it's not a perfect square. We also know from the last unit that we do not like to have radicals in our denominator, so we need to rationalize this denominator. So I ask myself, what can I multiply 3 by so that I obtain a perfect square number? Well, I know that if I were to take the square root of 3 divided by the square root of 3, I have multiplied by a form of 1, giving me the square root of 3 over the square root of 9. Going back down to our original equation, I'll have x minus 1 equals plus or minus the square root of 3 over 3, since I now have the square root of 9, which gives me positive 3. X still isn't by itself, so I need to add 1 to both sides, giving me x is equal to 1 plus or minus the square root of 3 over 3. Let's say I have 1/3 x squared minus x plus 7 equal to 0. Let's first start by getting our x's on the left and our number on the right. So let's subtract 7 from both sides. I see at this point that I have a number in front of x squared, but instead of dividing by 1/3, it would be better if I multiplied everything by 3, such that 3 times 1/3 will give me 1. So I will distribute 3 to each member inside our parentheses. This will give us x squared minus 3x equal to negative 21. I can now take my middle term, negative 3, divide it by 2 and square it. So I cannot simplify negative 3/2, so at this point, I'm going to be reusing that negative 3/2 when I factor, so keep that in mind. Negative 3/2 squared gives us 9/4, which I know I have to add to both sides of my equation. This gives us x squared minus 3x plus 9/4 equal to negative 21 plus 9/4. Negative 21, when you're writing a common denominator, is the same as negative 84/4. So I can factor the left-hand side now, again using the piece right before I squared. This becomes helpful when we factor, giving me x minus 3/2 squared equal to, now that we created a common denominator, negative 84/4 plus 9/4 gives me negative 75/4. I can now take the square root of both sides. I was able to, we'll step back here real quick. On the left, the square root and the square disappear. Notice I have a negative inside my square root, so I can not only eliminate my square root and my square, but my negative can come to the outside to give me plus or minus I square root 75/4, which we now will focus on simplifying that portion. 75 is the same as 25 times 3. So I can take the square root of 25 and I can take the square root of 4, giving me 5i square root 3 over 2. But x still isn't by itself, so I need to add 3/2 to both sides. This gives us 3/2 plus or minus 5i square root 3 over 2. But I noticed that they both have the 2 in their denominator, so I could also write this as x is equal to 3 plus or minus 5i square root 3 all over 2. Either case are perfect for me, whichever is your preference. This concludes solving by completing the square and the square root property. Next time we'll talk about solving using the quadratic formula.